In this video we're going to look at how memory works and how the computer uses its resources, that is the memory and the time that it's got. So we're going to take a look at something called multitasking. In a previous video you saw that it could be running many programs in the background at the same time. The problem is that a computer has the items loaded into memory, and below we can see an example of it. So I've got an action, a task called load Word document in sort of a yellow color. Then I've got print an image in a pale blue, and finally get a web page, because that's what you've asked for, in sort of lime green. Now the load in the document, depending on how long it is, might take quite a long time. And with this loaded in memory, the way that it's supposed to work is that it would have to wait all this time until the document has finished loading before it then starts printing the image. And if it's a really large, colourful image, that also may take a long time to actually print. And finally, once the image is printed, then we can try and get our web page, which again, depending on how quickly the servers respond, could be quite a long time. So these are tasks: load a Word document, print an image, get a web page. They're tasks, and if we had to run them in this order, in other words, wait for the Word document to finish before we printed the image, before we get the web page, the computers would be incredibly slow. You probably wouldn't see your web page for quite a while, if at all, depending on what happens with printing the image. So this isn't a very good way of doing things, but unfortunately that's how the tasks are actually in memory. So what it does is something called time slicing. And to go there, what I'm going to do is, instead of using the words load Word document, print image and get web page, I'm going to change those to L for load, P for print and W for get web page. So it's exactly the same. I've just changed what's written on them. So a computer does something called time slicing. In other words, it takes this task and how long it takes, and it slices it into lots of little bits, and with the print and with the get the web page. And what it does is gives a little bit of time to loading the Word document, then it gives a little bit of time to printing the document, then it gives a little bit of time to getting the web page, and then it cycles back to loading the Word document, doing a bit more printing, getting a bit more of the web page. And that way it appears that all three things, the loading of the Word document, the printing of the image and the getting of the web page, are all happening at the same time, or pretty much at the same time. This is called time slicing. So it's taking the actual task, breaking it down to smaller bits and allocating a time slot for it. Now, although I've got them in the same order here, so the L comes before the P, comes before the W, that's not always needed. It could be in a completely different order. And we'll take a look at this time slice here, where we start with the loading of the document, then we start with a bit of printing, then we start with getting the web page, then we go back to the printing, then we go back to loading a bit more document. Now the reason for this is that sometimes the printing might need more of a time period, might need double the amount of time to finish its task. And whereas if we're loading something from a word processor, it might stop at a point, wait for something to happen. Are you sure you want to load this document? So you've got a message on the screen waiting for you to click OK. And so it will allocate time to other processes, other tasks, while it's waiting for that to happen. So although it's slicing these programs up into time, they do not necessarily have to be in the same order. This is how computer memory works and how the tasks work. It's a very simplified version. As you've seen, there could be 30, 40, even 1,000 programs running, and each one of those programs is being broken up and given a very small amount of time, only milliseconds to run. Milliseconds in a computer is a long time, but to you, you don't notice it. So, for example, if this has got 1 millisecond, 2 milliseconds, 3 milliseconds, 3,000ths of a second, you wouldn't notice it before it goes round and does it all again. So that's called time slicing and multitasking. It's important to know how that operates.